Hey there, listeners. Welcome back to the Modern Brewer Podcast with me, your host, Chris Lewington. I'm going to take this episode to run through the results from a trial I recently conducted with the amazing Gipsy Hill Brewery in London, Pneumatech, nitrogen generators, and H&M Compressors and Pumps. This is exclusively the first place this case study will be aired. It's going to be in the Brewers Journal, hosted on various blogs, including Brew Resourcefuls, and there will be some good noise about this. I hope this exclusive first access is a reward for all the loyal listeners to this show. But before we get in any further, an awesome new feature has just arrived in the world of podcasting, which is super exciting. If you happen to listen to this podcast on Spotify, you can now interact directly with me. They have literally just released this feature. Simply click on the episode on Spotify and put a comment. If you have any questions, please put them in straight there. Or if you have any nice feedbacks or suggestions for improvements, please put them in there as well. I often get comments in my LinkedIn or IG DMs, which I always answer, and they mean a lot to me. But this way, we can have a more public platform to discuss, and perhaps other listeners can add their comments too. Before we dive into today's episode, I want to share with you a company that is top of the class in custom apparel printing for the brewing industry. I've been wearing their prints for nearly my entire brewing career. When it comes to custom prints and embroidery, we all want vibrant, precise, and durable merch. That's what sets your brand apart. And we have seen brewery merch move from something that's just sold out of the tap room on a Saturday to becoming lifestyle clothing brands and significant revenue streams for breweries. So I'd like to introduce to you Fifth Column, the ultimate solution for all your custom apparel needs. Whether you're a business looking for promotional items or someone wanting personalized clothing, they've got you covered. High quality screen printing is at the heart of what Fifth Column does, offering vibrant prints that last. Their expert embroidery services deliver detailed and, most importantly, durable designs on a wide range of fabrics that can withstand the test of time, even in the toughest production environment. Now, something that's close to my heart. Fifth Column are committed to sustainable practices, using water-based inks and ethically made materials wherever possible. They actually have the largest range of ethically made organic cotton garments in the UK. This means you are getting high quality clothing and printing that isn't costing us the earth. Efficiency is key to their production process, ensuring your orders are completed and delivered on time every time. I have used Fifth Column for years and they never missed a delivery for us. Plus, with their efficiency comes highly competitive pricing. Their experienced team with years of passion and dedication ensures that every project meets their high standards. And if you're planning a large order for an event, corporate gifts, or merchandise, Fifth Column's bulk order discounts make it even more cost effective. Fifth Column serves local businesses in the UK, but if you're an international listener, don't despair. They also serve a large range of international clients, a testament to their ethics, quality, and customer service, which has seen this garment and printing company continue to grow since 1977. When you think about how much that industry has changed since then, it's actually quite incredible. And get this, the team at Fifth Column are offering you, the listeners of the Modern Brewer Podcast, 10% off your first order. So if you're ready to take custom apparel to the next level, visit their website at www.fifthcolumn.co.uk. There's also a link to Fifth Column website in the show notes. So let's get back to it. Everyone knows I'm on a quest to eradicate purchased CO2 from breweries. It's always been a standard in breweries to purchase CO2 in canisters, bulks, or delivered into storage. But that time is over. The combination of a 3,000% price increase, supply shocks leaving breweries without the critical process gas, and our move to a more sustainable industry by not supporting the fertilizer industry and not purchasing something that we readily generate ourselves has meant we all now have the desire to move away. And recently we have finally have the options available to craft brewers on every scale. The choice is CO2 recapture or nitrogen generation. It's pretty straightforward. Luckily, I have episodes on both. In episode 17, I had the team from Dallam to discuss their incredible, and I really do mean that, incredible craft scale CO2 recovery unit. In episode 15, I had Alex Redpath from Full Circle and Craig Smith from Pneumatech discussing N2 generation and how Alex has replaced 85% of his purchased CO2 with a nitrogen generation unit. I must say, that episode 15, is a must listen if you want to get the most out of this episode, as episode 15 goes over the key principles of nitrogen generation, which will most likely not be getting covered in this one. So let's discuss why we are trialing the purity levels in nitrogen. So commonly, 99.9% purity is required for breweries, but what I wanted to prove or disprove is 99.5% good enough for the craft brewing sector. Purity is important because it costs 19% less electricity to produce 99.5 versus 99.9. It costs 19% less electricity to produce 99.5 versus 99.9. So with a Pneumatech pressure swing absorption nitrogen generator, a meter cubed of 99.9% nitrogen will cost 0.33 kilowatts, and 99.5 will cost 0.27. For you, the user, it would also mean a smaller unit with less capex and less space required to run a 99.5% generator. Importantly, in terms of environmental savings, the kilos of CO2e of producing a meter cubed of 99.9% is 0.068 kilos or 68 grams versus 99.5, which is 55 grams or 0.055 kilos of CO2e. So that might seem minor on a brewery level, but this has a huge impact on the industry level. If all craft brewers were to optimally go for 99.5 instead of 99.9, that would see a significant reduction in the amount of carbon emissions it takes to produce nitrogen in a breweries, which is why I found this research really important to get done now, because we are on the cusp of replacing all purchased CO2, and I strongly believe nitrogen generation and CO2 recapture are the only ways for us to do so. So I want this research to come out now as everyone is making their important decisions. In this trial and resulting case study, we set out to find out if 99.5% purity is usable in a craft brewery setup. What ends up happening is an overall question to craft brewers on what dissolved oxygen specs they have, how they are measuring, and why are they the way that they are. I have not done this alone. First big shout out is to Fred, Jim, and Steve at Gipsy Hill Brewery in London, who facilitated the trials and did all of the legwork. I'm just the ideas guy these days. Another big shout out to friend of the show, Craig Smith from Pneumatech, who lent Gipsy Hill one of the nitrogen generators they have just to prove or disprove this trial, which is super generous as they have a whole bunch of customers just waiting for that trial unit. Another really important and final shout out to Tom Hennon of H&M Compressors and Pumps. Honestly, I wish I'd met Tom when I was in breweries. He's just one of the best and most progressive people I've ever worked with in any of the service industries that come into the breweries, but especially in compressors and pumps. Tom and the team are just elite. He also lent one of the trial units for free just so we could get these trials done, because he cares about the outcome of these trials, what it means for the industry, and what it means for the environment. So a big shout out to Tom and a big shout out to Craig, and of course the guys from Gipsy Hill as well. Okay, let's quickly run over the kit that we had just for anyone who might be interested. This was not enough to cover the whole of Gipsy Hill's production to make this point. It's just to cover the prospect of the trials. But for anyone who's interested, what we installed was two 4-meter cubed an hour nitrogen generators from Pneumatech. We had one 1,500 litre air receiver capable of storing the nitrogen for the high peak demand periods. Gipsy Hill already had their compressor, which was large enough with enough capacity to take the additional load of the nitrogen generators. All of this was actually installed by Tom in just one day. The floor space is literally next to nothing. These units are like chest height, a forearm wide, and like half of that deep to paint a picture. These things are tiny, and they were capable of doing all of the work and with loads of excess for what we were doing. So how were we planning on replacing CO2 with 99.5% nitrogen? Let's first start by just going over a very high level of how Gipsy Hill's standard process for beer goes, because that's an important start to this, as it just gives you a bit of context as to what I saw when we first walked in. So, I mean, it's all pretty standard. There's only one unusual bit, which is really cool, actually, and will hopefully be a different podcast coming up. But the standard is they're wort into FV. They then dry hop that FV. Now, the interesting part is they actually centrifuge that FV through a decanter to scavenge the hops from the tank bottoms. They then reuse these hops in the whirlpool of different brands. So they're actually maximizing their raw materials there. It's super, really sustainable, thwart with what I would think would be loads of IBU issues. So it's going to be really fun to have those on, like Fred and Jim on the show to talk us through how that process looked for them, because I think it's awesome. But yeah, that is unusual, but not covered in these trials. They then transfer that FV that they've now gone through the decanter into a BBT. The BBT is then carbonated and it goes into a packaging unit. They package in either cans or kegs. They're actually one of the rare breweries in the UK that seem to clean and purge their own kegs, which is going to be pretty useful later on. We already know that 99.9% nitrogen can replace all of the CO2 processes we've talked about here. Some questions do lie over the decanter. We did not do any trials on that, and maybe in the future we will, or I hope Gipsy Hill will, and that would be an interesting part for anyone who's going to be running a decanter, although I think that applies to about 3 or 4 breweries in the UK, so maybe not got the mass appeal. But 99.9% N2 has been successfully done in many breweries across the country. I mean, look, including episode 15's Full Circle. So if you want a real life case, please listen to that episode and listen to Alex go through. He's using 99.9% purity and achieving everything he was with CO2, bar carbonation, of course. So the question is here, really, can we still achieve Gipsy Hill's DO specs, both in liquid and in the gas of the tank after the purging process, before they fill? So let's start where we started. I really wanted to start this with just the classic purging of BBTs. And that's really where that was the first process we wanted to replace, just because it is the easiest one to do in a brewery. There's always a spare tank knocking around, and ultimately we can do the specification, and if it doesn't hit it, then we can move on. But yeah, let's talk about purging BBTs and FVs. Where is the manual on that, I ask? I think that could be an episode on its own. So many breweries I visit, in fact, I'd say every brewery I visit has its own unique way of purging a tank. And I'm yet to see anywhere online, really, or in any article, I hope I'm wrong, which through the science behind how purging works and what is the optimum method of purging. But generally, there are 3 main methods that I see in breweries. You've got the low and slow. So the pros of this are going to be like efficient uses of gas. So, I mean, if you're just going low and slow, it takes time, but you are using the least amount of gas possible to purge that tank. Of course, I just mentioned the downside is definitely that you have to use quite a lot more time. And with CO2, you shouldn't be leaving that on overnight. I don't think many breweries would, but that is also a problem because there's a lot of dead time, which would usually be great for purging with the low and slow method, but not possible when you've got CO2 because all it takes is one one like loose connection, you lose a whole cylinder or a whole tank or a whole bulk tank of CO2. The brewery's full of CO2 in the morning, it's like asphyxiation, like genuinely just a whole bad thing's going to happen. So the risk is so high that I don't see any breweries do that. And the challenges with that, with the low and slow method is, I mean, yeah, the accuracy and stability of flow is always one. How good are your regulators? How good are your spuns or pressure release valves? Like, how good are these and how reliable are they? Because they have to be very reliable for this method to work, because it's very easy for them to start balancing out, and then you're actually not putting anything in the tank and it's just dead time. And then there's also a really good one. I think this is probably underappreciated in breweries, but the tank design is actually really important to where you purge, because classically with CO2, you'll be going through the bottom of the tank, purging up through the exit of the tank at the top and out the side arm. Now, the good question here is, where is that exit point? Because it can be counterintuitively, but it is actually not at the top of the tank, especially if you've got one outlet, which is the spray bore, your CIP spray bore, which usually sits around like 15-20% from the top. So where your Krausen sits is generally where your CIP spray ball sits, so about 15-20%. So that is a big chunk of that tank at the top that if you go low and slow, you're actually very rarely disturbing. Especially if you go very low and very slow, then you are actually not disturbing that pocket at the top. So that means you now just have a pocket of air that's getting trapped at the top. So you can measure your tank, and generally you'll probably pass, but you'll have that pocket of air. So that's kind of a downside of the low and slow. Then there's the good old one, the rough and ready, I call it. So, I mean, this is just where you get a CO2 line, you attach it to the bottom, and you absolutely yam CO2 in that tank until you get a pass on the tank. Now, look, it's not pretty, it's not glamorous, but have we all done it? Most likely, yes. Well, I mean, it works, right? That's the worst thing about this. It works. It's super quick. You can have tanks down into spec, big tanks down into spec in only like an hour, sometimes less. So, I mean, that's pretty great when you've got a busy production schedule. I mean, obviously, the big downside here is it uses a colossal amount of gas, super inefficient. And with the prices of CO2, I mean, that was an expensive decision to make now. So, yeah, there is to some extent a bit of a safety concern, especially if you're letting it out of the side of the tank for whatever period of time, because the quicker you go in, the quicker you come out, and then you're just filling the brewery with CO2. So if you haven't got a CO2 safety alarm system, then that can very quickly become quite dangerous. And we've seen it. I've seen it in real life. We had a CO2 alarm system installed at one of the breweries, and we were super busy on production, so we were yamming. We were doing the rough and ready method, and it wouldn't take a tank an hour and a half. If you left it on for an hour and a half instead of an hour, the CO2 alarm would start going off, which is actually pretty scary, especially if you put a couple of tanks in there. So you've really got to actually be quite conscious of that. And I think in previous episodes, but even a mild level of CO2 is really harmful over the course of time. It's a mild asphyxiant, so it actually starts to starve your brain of oxygen. It's pretty grim. So generally, really don't want to be overdoing it with the CO2. And then there's a third method, which is I haven't seen loads of, although we will go into that later on in this case study. But it's the fill and dump. So this is where you fill the tank with CO2 or your gas, and then up to a certain pressure, probably around a bar, depending on the working pressure, and then you drop all of it out, and then you repeat that process until your tank is in spec. So, I mean, the good side of this is it's easy to replicate. I mean, pretty much anyone can do it without too much deviation. It can be fairly quick, depending on how on it you are with the opening and closing. I could also argue it could be a bit more labor intensive. And to be honest, that would definitely work. That sort of method works in every tank type. So even when your CIP spray ball is 20%, is your exit point 20%, this method will capture that, because that agitation of that initial high pressure purge will mix everything up. So that would work. Look, I mean, I don't think it's a massively efficient use of gas. Low and slow, I think, is clearly the most efficient. So it works. It's a bit of an inefficient use of gas. And what actually ends up happening, we'll talk about where you measure in a second, but with this method, you replace the entire tank with CO2 that's in spec, and is that actually necessary? We're going to go through that. So there's also there are some safety concerns with this as well. Like, where are you exiting that CO2? I really hope that that's in a piped outside at least, so it's not in the brewery, to go back to my previous point of how unsafe it is. So yeah, there's also max working pressures of tanks. So sometimes they're really low in some breweries I've seen, and they half a bar or something, which means this method will take a very long time to do. So it probably wouldn't even exist in that brewery. So there are probably loads of other methods I haven't mentioned here, but they're the three main ones I've seen and used two of them before in previous experience. So I'd say that generally those three probably cover the majority of them. And Gipsy Hill actually used the fill and dump method. So that was their standard method of CO2 purging. And yeah, I mean, all of the CO2 was piped outside from the tanks, all like that. It was a really nice little system. Their purging took around an hour and a half, 2 hours. So it's actually pretty quick. Again, it's very dependent on the brewer being there to empty and stop, because that could easily take 5 hours if someone wasn't on it. But yeah, when someone on it, they could get it in an hour and a half, and probably even less if they were really on it. But very brewer dependent. And yeah, so the main thing and the main concern with nitrogen is that, look, nitrogen is a lighter gas than CO2. No messing around with it. And it's even lighter than oxygen itself. So to give you a scale, nitrogen is 28 grams per mole. Carbon dioxide is 44 grams per mole, and oxygen sits in between at 32. So nitrogen's 28, oxygen's 32, and carbon dioxide is 44. So you can see why carbon dioxide has been the preferred gas for many years in the brewing industry, because it's heavier than oxygen. So there is solid theoretical basis to say that it is way easier to displace a lighter gas with a heavier gas than displace a heavier gas with a lighter gas. So it makes perfect sense theoretically. So how can it be used in a brewery situation? Because as we just said, it's a lighter gas. And well, yes, it can. It will act differently and is theoretically, of course, harder to use, but actually in practice, which is really important, the difference between theory and practice in breweries, but in practice, many brewers, I mean, this including Alex and Full Circle, they simply just changed the CO2 for nitrogen and kept their purging technique the same, and I've never looked back. The specifications are exactly the same, nothing has changed. So yes, there is a fear there, but the actual reality is way less impactful than you believe it will be. So I'll be honest, the science of purging seems to be well known as the meaning of life, as I said before. Everyone has opinions on it. It's really interesting. Myself included, very strong opinions for a very long time. Everyone has their own methods. And as I said, rarely two brewers are the same. But we all get there in the end. We all get to the specs that we want. It's probably why no one's ever spent loads of time working on it. But yeah, I mean, as I said, if there's anyone listening who actually has a really good, solid scientific understanding of this, please let me know. I'd love to have you on the show and we could talk about it, because I think it's such a fascinating subject. So yeah, I mean, effectively, can N2 be used? Yes, very easily. The challenge of this case study or this trial was actually not really to show that N2 can be used as a gas, because I'm extremely confident, as I've seen it in many places and used nitrogen myself, so I know that it works as standard. But it was the purpose of this trial was to prove, can an impure or a less pure nitrogen still have the brewery application. But as we go through, I will actually talk through in good detail about how we change nitrogen, how we change CO2 to nitrogen, because I feel like that's just going to be useful as we go along. So if you still have some concerns over whether nitrogen can be used, please do continue to listen, because this is definitely going to alleviate those, even more than just a brewer telling you, yes, it will work. This is like a good trial, so hopefully this will give you some additional confidence. Okay, so now let's talk about specs, specifications, and methods of testing. It's going to sound a bit drab, but actually the key to this case study is making it applicable to all breweries. So I want to get everyone on the same page and at least the same understanding as to why I've gone ahead with certain parameters, etc. during this case study. So for those fortunate enough to be able to measure their dissolved oxygen, there might be some interesting differences here. Is ultimately you're limited to what your instrument can measure. The Anton Paar C-Box, a staple in most medium-sized breweries, is actually not designed to measure oxygen in gas. And in theory, its results are invalid. So if anyone's used the Pentair Haffmans CDGM, it's far clunkier as a machine, but it's actually capable of measuring oxygen in both the liquid and gas. There are other units on the market outside of the Haffmans and the C-Box, and I'm not going to go through every single one, but these are the two main ones I see and have used. So I strongly recommend that you check the manual of your DO meter to see if it can be used to measure gas and liquid. Generally, if there isn't a setting to tell the machine what you are measuring, I'd probably say that's not a good sign that it can accurately do it. But please still go and check, and it's always good. It's always a good manual to check anyway. But anecdotally, and I do stress the word anecdotally throughout this next part, is I've worked in a brewery that had both the Anton Paar and the Haffmans machines because we were so spoilt. So we got to run some side-by-side trials. Now, I can safely tell you that anecdotally, there is little difference. So there is a strong correlation between the percentage of O2 as air and the ppb reading you get on the C-Box, which is supposed to measure liquid. As this is far from white paper material, I'm hesitant to kind of share loads of information on this trial, but feel free to drop me a line in the comments on Spotify or contact me via like LinkedIn or email. We can discuss in a slightly more informal setting. But yeah, basically, we saw a strong correlation and we're very happy to use them interchangeably should we need to, especially when one goes off for the inevitable 6-month-long service. Now, I know the majority of brewers will be measuring the effectiveness of their tank purges using parts per billion or ppb. So for the sake of continuity and ease, I will use ppb as the main unit going forward. Now, I know that's not scientific, but ultimately my goal of this case study and the content of Modern Brewer Podcast is to be as applicable to the real world brewer as possible. So that's what I'm going with. Feel free to smite me down. I'm not afraid. I might occasionally drop in the percentage of O2 as and when, just so give it a bit of context. But ultimately, I'm going to go ahead with the ppb. So yeah, any questions, just let me know. Okay, so let's talk DO specs to pass a successful tank purge. Well, I say DO, it's actually not technically true, but again, we'll lose the science side of this and go for the real world application. So when you're measuring that tank purge, once you're measuring the gas after your tank purge, what is the specification to say that that has been successful? I mean, think about it now. What are yours? Are they 500 ppb, 300, 200, 150, 100, or even as low as 50 ppb? I would say the vast majority of you would say, including myself in this, 50 ppb, perhaps ranging up to 150. And look, we all know why, because O2 is the enemy of craft beer. I'd also say some will look at their beer DO specs and draw parallel lines across to make their purge specs. So they'll look at, we don't want any more than 50 ppb in our beer, so why would we want more than 50 ppb in our gas? Is 50 ppb too tight? This is a fantastic question because I've used, as I said, 50 ppb for the vast majority of my career, but I was often challenged on this by large brewers that I was working with. I mean, look, when I say challenge, they would actually literally laugh in my face, but it's okay. I'm definitely over it. Most large breweries use 150 ppb to 300 ppb with little DO pickup in their beer. So how is this all possible? Well, the difference here is measuring oxygen in gas versus it dissolving in your liquid. Your DO levels in beer are affected by the atmospheric O2. All of this happens under Henry's law. So what is Henry's Law? Henry's Law is a gas law which states that the amount of gas that is dissolved in a liquid is directly proportional to the partial pressure of that gas above the liquid when the temperature is kept constant. So this means that the atmospheric DO will dissolve into the liquid. So the higher the O2 concentration, the higher DO in your beer, or dissolved oxygen in your beer. Ultimately, this boils down to how you carbonate. If you carbonate your beer through head pressure, 50 ppb is a seriously important spec because it means that there's less O2 that's going to get in your beer, especially over the course of time and the differential in head pressures and the pushing the liquid. So if you do not carbonate through head pressure, then in a way, the O2 concentration in your headspace isn't as important as you might think it is. So with all this in mind, let's talk about Gipsy Hill's specification. Their specification to pass a successful purge is actually 200 ppb. Now this to me is actually super smart. Because they carbonate through the carbstone and they package very quickly, there's very little time for oxygen to transfer from gas into the liquid. So they actually pick up no measurable additional DO during their BBT storage phase, even if it's over a weekend or over a longer period of time, even though that, in theory, that headspace is 200 ppb as opposed to what the common craft beer spec is of 50 ppb. So I find that fascinating and something that I hope is challenging the way that you might be looking at your specs. So I think that actually 150 to 200 ppb makes perfect sense for headspace. Finally, where they measure is important. So throughout my career, I've always measured from the sample port. So the concept here is you go in with the CO2 in the bottom of the tank, you purge up, and you measure from the sample port. Now this proves, if this passes your specification, whatever it may be, this proves that between the bottom inlet and the sample port is of the specification. So I would say this acts as a cushion between the beer and the air. So when you are entering beer into the tank, you are pushing that blanket of CO2 up and you are pushing the remainder of the air that's in the tank out of the sidearm into the atmosphere or wherever it is going. Now, Gipsy Hill as a standard measure from the sidearm. So they measure that their entire tank is in spec before they transfer into it. So this is the sampling method that we did throughout this process. Okay, so now we've gone over in quite granular detail about Gipsy Hill's processes. We've talked about purging, specifications, everything. Now we're going to get into the nitty-gritty of the actual trial itself. Is 99.5% nitrogen pure enough? Has a lower enough oxygen content to be used as a purging gas in a craft brewery setup? So the first thing we did was we purged and filled the air receiver and we measured the O2 in this air receiver. If this was out of spec, then this would instantly disprove that 99.5% is fit for the craft brewery, because if your gas itself has got a higher concentration of O2 than your specification, then in theory it will be very difficult or impossible to achieve your specification. So that was the first test. Now, the readings came out at, on average, of 190 ppb, or 0.19% O2 as air. So that is tight. So spec is 200, and the actual reading itself is 190 ppb. So if you need, and I do mean if you need 50 ppb as a specification in your brewery, then 99.5% nitrogen cannot be used. Importantly, 99.9% can be readily used, as with Alex at Full Circle, whose specifications are 50 ppb across the board. So this is not to disprove the nitrogen, just that 99.5% is not pure enough to get 50 ppb specs in tank purges. It does mean, for the purpose of this trial, we have our work cut out, because the gas we are purging with is only 10 ppb less than the target. Okay, so what happened with the first tank purging? What we wanted to do is emulate their exact procedure. As I said earlier, they use the fill and dump method, and it usually takes between 3 and 5 empties, or fills and empties. So we started measuring the tank before. It was completely out of range on the Haffmans, so we couldn't get a reading on it. And by purge number 5, which is the most it would usually take with CO2, with nitrogen, we were out of spec. We were 800 ppb in the tank. So we trialed several more times, very similar results. So in this example, in the Gipsy Hill case, the fill and dump method was actually not working for nitrogen. We couldn't get that beer into spec we could, but not within a reasonable amount of time. So we switched to the low and slow. One of the many advantages of nitrogen over CO2 that in theory it can be left on overnight, because leaks are not as much of a concern because you have an unlimited supply versus a bulk tank or a canister. It's less dangerous as a gas. To walk into a brewery full of N2 is less bad than as a CO2. I would still recommend an O2 sensor in the brewery for that. There are some couple of concerns here. You just want to make sure that you would normally leave your compressor on overnight. Otherwise, you are just adding an additional cost to this. But Gipsy Hill, their compressor ran overnight and they were comfortable to leave the N2 running overnight. So they would set the nitrogen coming in from the bottom, as you would with CO2, and then they'd measure from the sidearm as they would with CO2. So it did actually achieve the specification, but it took a very long time to do so. So it was taking longer than overnight. So they would set it before they leave, they'd come in the morning, and they would still need an additional 3 or 4 hours of purging. So what Gipsy Hill did was they actually switched from purging from the sidearm and measuring from the bottom. So they're using the logic of a lighter gas here, which would force the heavier gas out the bottom rather than trying to displace the heavier gas out the top. This worked. Now, they could set the purge before they left, and in the morning, the tank would be in spec. So for them, this aspect of the trial was complete. They could get the tanks in spec before the day they needed them by just leaving them overnight. Usually cleaning would take place on that day, purge it overnight, and then be ready for the next day for transfer. So that worked. I mean, for those looking to get tanks done quickly, Alex at Full Circle purges his tanks in a few hours. So we did not feel the need to do these trials on that purge technique. We were happy with what was being done here, but it would have been possible to do the same with that gas. Now, here comes a really interesting part, which is pushing out beer with nitrogen or leaving nitrogen as a head pressure, equal parts. So I always hear concerns with this. Will the beer pick up nitrogen? Will I lose CO2? And will it act differently to CO2 as a top pressure? So first, let's talk about maintaining carbonation. CO2 is highly soluble in beer, while nitrogen is much less soluble. For anyone who tried to nitrogenate a beer, they totally understand what I'm saying. When beer that's been carbonated with CO2 is subjected to a top pressure of nitrogen, the CO2 in the beer remains relatively unaffected by the presence of nitrogen. The CO2 will stay dissolved in the beer as long as the pressure of the CO2 in the headspace is sufficient to maintain equilibrium according to Henry's law. However, if the headspace pressure drops significantly, CO2 will start to come out of solution, leading to a loss of carbonation. So now let's consider the impact of nitrogen pressure. Since nitrogen is much less soluble in beer than CO2, applying nitrogen pressure won't significantly increase the nitrogen content of the beer. However, the use of nitrogen can affect the CO2 pressure in the headspace. If the headspace is predominantly nitrogen, which it will be in this case, the partial pressure of CO2 in the headspace will be lower, potentially causing CO2 to come out of solution to re-establish equilibrium in the headspace. This is where mixed gas has come into play in dispensing systems. So by blending CO2 and nitrogen, they ensure that there is enough CO2 pressure to maintain the carbonation, whilst the nitrogen is a cheaper alternative to maintain that pressure. So let's break it down into more practical scenarios. If we're using a pure nitrogen, 99.5 or even 99.9, is used as top pressure, the partial pressure of the CO2 in the headspace will decrease since the total pressure is now comprised of mostly nitrogen. As a result, the equilibrium shifts and CO2 may begin to come out of the beer, leading to gradual decrease in carbonation levels over time. This process is slow, but noticeable only over a long period of time. This is absolutely key information. If you plan to leave your beer in bright beer tank for prolonged periods of time, then either mixed gas or CO2 should be used, especially if there's no way of changing carbonation in BBT. In Gipsy Hill's case, 1 to 2 days of storage time, we saw absolutely no effect on the carbonation within the accuracy of the Haffmans. So speculatively, this could be left for a week with only minor differences. So this proves you can use nitrogen as a headspace gas, and also that it's clearly the right gas to use to push your beer out of your tank into your packaging lines. What is really important in this, especially with Henry's Law, is the amount of headspace. So as you will all know from experience, the larger the headspace, the quicker and more dramatic Henry's Law is seen. You've all seen if you leave half a tank of beer with the same head pressure as you usually do, you'll see a violent swing in CO2 when you come to check it the next day. And that case applies here. The greater the headspace, the quicker the loss of CO2 into the nitrogen. So it's really important that you actually have very minimal headspace for this reaction to take as long as it possibly can. If you're operating on 30, 40, 50% headspace, then nitrogen becomes quite a risky gas to use because the quantity of CO2 that has to come out to balance that equilibrium is far greater, which means you'll see a much bigger change in your carbonation level in your beer. So a really important point is to make sure that BBTs are fairly full. Of course, there's going to be headspace. So now let's move on to cleaning and purging. For me, this is the main reason nitrogen is a better gas than CO2, as it does not react negatively with caustic. So Gipsy Hill trialed measuring the O2 content after the tank had been pushed out with nitrogen and then after the tank had been CIP'd, because my logic was that if you've pushed out with nitrogen, you don't need to do the whole replacing the CO2 with air, then you should have a higher concentration of nitrogen, a lower concentration of O2, and therefore you should be able to clean and then purge. The second purge should be a lot more minimal than the first purge because you've effectively not replaced the tank with air as you normally would with CO2. With CO2, you just have to constantly do the same purge every time because you have to remove all of that CO2 at the end so it doesn't react with your caustic. So this is what Gipsy Hill trialed. Now, the first results are not quite as concrete as I expected. So this is what happened, and here is why. When Gipsy Hill pushed out with nitrogen, they went straight on with the CIP, and they used hot caustic. And what they did was they detached the ports as usual, and they ran them with hot caustic as normal. And then they went and used ambient water to cool the tank down with and to flush out the caustic. Now, what happened here is with the ports open and that pressure and that temperature difference causes a little slight vacuum. So it drew air into the tank. Now, this was enough air to knock it well out of specification and requiring not far off a full second purge. So with the hot caustic and then the cool water and the tank open, as it would have to be, then this kind of stopped this theory being true. So they moved to a cold caustic cycle, and they also kept the ports on. So they purged with nitrogen first, filled the tank with beer, pushed the beer out with nitrogen, and then CIP'd cold with the port still on and about 0.5 bar of pressure on. They did the full CIP, passed all their specifications as normal, and this meant that actually at the end of their CIP, the tank was sat at 160 ppb, which meant that they could go straight into it. They didn't have to do any second purge. So that is huge. This means that there's no emptying of CO2. So that's 30 minutes with water plus the cost of using water to empty the CO2 out of the tank, or about 6 to 12 hours if left open. It meant no more CO2 in the production area when valves would be taken off, and no more repurging. So tanks could just be refilled as soon as the CIP is done. For Gipsy Hill, this meant an increase in BBT capacity of 30%. That's the equivalent of them buying 1.8 more BBTs. Now that is absolutely huge. This was possible with 99.5, but if your DO specs or your purge specs are tighter than theirs, this would work with 99.9. So in conclusion to all of this, the purity of your nitrogen is solely dependent on your specifications. If you are at anything below 200 ppb, from the trials that we conducted, 99.5% is not the correct purity. You would need higher, 99.7 or 99.9. So that's important. But what was really interesting about this case study, and I hope for the people who have stuck through and listened to it, is that actually it works as a head pressure gas, and it works as a push-out gas, and it works as a purge gas. So therefore, you can replace a huge proportion of your CO2 usage with nitrogen. And in doing so, you can decrease the amount of time it takes to turn over a tank and increase your overall utilization over the year. And in Gipsy Hill's case, that was an increase of 30%. So it's just huge. This is coupled with all the other perks of nitrogen, which is it's cheaper to make, it's better for the environment, it's better for production staff, it's a safer gas to work with, it relies more on self-sufficiency, and it doesn't negatively react with caustics. These are all the things that nitrogen is doing for your brewery that CO2 isn't. Now, there are some next steps of this trial. There's some obvious glaring omissions here. One, I would love to trial 99.6, 7, and 8 to get a whole comprehensive data set. I will work with Gipsy Hill over the course of time, and hopefully we can get some data out on this. The next step is also we are going to test the DO pickup of 99.5% in kegs. So there's no question that you can use 99.9% nitrogen to purge a keg. Let me tell you, if you can purge a vessel, you can certainly purge a keg. So there's no question of that. The question is, will that increase in dissolved oxygen, will that mean that you have an increase in DO in your beer? The big one is canning. So N2 is used in canners around the country. Alex, again, in episode 15, goes over that. But is 99.5% enough? I do feel this will be a stretch too far. TPO in canning is hard enough to reduce, especially on the non-rotary canners that you see commonly in craft breweries. So I would be unsure of whether this is good enough, the 99.5. Gipsy Hill did say they will trial this, but that will take a bit of time, and that update will come in the future. So if you want to stay up to date with this, please follow me on LinkedIn. There'll be updates coming out on there, and the full case study will be released on LinkedIn and on my blog. You've had the first early access preview of it, which is exciting, but the full thing will be coming out shortly. And as I said earlier, if you've got any questions, comments, or concerns, please let me know in the comments on Spotify, email me, or keep up the LinkedIn DMs. My contact details are always in the show notes. I really hope you liked this episode. Once again, it's a stray from my normal style, and I feel like I've done so much talking. So please let me know your feedback. It's so important to me. If you like the show in general, please can you leave me a review on Apple or Spotify? It really helps me grow the show. It means I can attract even more elite guests, and generally it's just nice to see the show supported. Again, one huge, massive thanks to the team at Gipsy Hill, Craig Smith at Pneumatech, Tom Hennon at H&M Compressors and Pumps for making this all possible. I think this research is really cool. I was so happy to be a part of it, and it's something I've been wanting to get over the line for such a long time, so I'm so stoked I finally get a chance to speak about it. The next episode will be going straight back to normal, and I'll be doing way less talking, listeners. So hopefully you can recover from the sound of my voice. In fact, maybe next time I won't even speak. We'll just get someone else on. So again, thanks so much for listening. And I will catch you on the next episode of the Modern Brewer Podcast.